Hello, Integrated Math 1. Welcome to Module 1, Topic 2, Lesson number 3. We're going to be playing with recursive and explicit formulas today. It's going to be good times. Now, I've already done the warm-up. We've already done the getting started activity. So we're going to jump right in here to activity 3.1. We're going to start looking at recursive and explicit formulas for our arithmetic sequences. Now, we've already talked about arithmetic sequences, how if we're dealing with an arithmetic sequence, that meant we were adding or subtracting a constant, right? And that we called that constant that was being added or subtracted the common difference. You're going to need to remember that, and you're going to need to know that to help you today. So let's start off with a recursive formula. What the heck is a recursive formula? So you can see it's in bold here on page M01-133 in your book. And a recursive formula expresses each new term of a sequence based on the preceding or previous term in the sequence. So the recursive formula to determine the nth term of an arithmetic sequence looks like this lovely bad boy down here. So the idea is that a recursive formula is just a way of helping us find a term by using the term right before it, all right? So for example, this says a sub n, and n is the term that I'm looking for. Let's say I'm looking for the fourth term of a sequence. So I would be looking for a sub 4. But that means I need the term right before it in order to find that term. So that's why I have n minus 1. So if n is the term I'm looking for, then n minus 1 is the term right before it. All right, so a sub n means, so if I'm looking for the fourth term, this would say a sub 4. And that means I would need a sub 3, right, 4 minus 1, the term right before it, in order to use my common difference, so plus d, my common difference, to help me find my fourth term, to add that common difference onto my third term to help me find my fourth term. So one of the nice things about the recursive formula is that you only need to know the previous term and the common difference. If you know the previous term and you know the common difference, great, add them together and boom, there's your next term. So for example, if I have a sequence like this, so I have -2, -9, -16, -23, and I'm like, okay, well, the difference between each of these is a -7, all right? So we're subtracting 7 every time. So I can use my recursive formula to help me find the fifth term. So here I have a sub n equals a sub n minus 1 plus d. This is our recursive formula for an arithmetic sequence. So if I want to find the fifth term, a sub 5, it would be equal to the term right before it, so a sub 5 minus 1, plus my common difference. And it looks like my common difference here is 7. -2 plus a -7 gives me -9, plus a -7, plus a -7, on and on and on. So here I'm using my recursive formula. So of course I know that 5 minus 1 is 4. So I'm going to plug in my fourth term. And if I look here, 1, 2, 3, 4, looks like my fourth term is -23. So -23 plus my common difference of a -7 gives me -30. And this tells me that my fifth term is -30. Now, you guys probably feel like this is a lot of trouble just to find the next term, but it's important that you understand how this formula works because we're going to use it and expand on it to do other cool stuff in the future. So this is our recursive formula. This is how it works. That if I want to find the fifth term, I need to use the fourth term and just add on my common difference to get there. So I would like you to consider this sequence showing Rico's contribution to the Centipedes baseball team in terms of the number of home runs he hit. So here's the deal. We talked about this earlier, right? We made a table earlier in the getting started activity with Rico contributing to the Centipedes, and we noticed that the sequence that we got was 125, 143, 161, 179, because of course he kept adding $18 for every home run that was hit. So he agreed to donate 125 and then add on another $18 for every home run that was hit. So I would like you to use a recursive formula to determine the 11th term in the sequence If you need to flip back to our getting started activity and look at the table, that's fine, then that's what you need to do. But then I would also like you to just explain what this value means in terms of this problem situation. So you found the answer, use a recursive formula, find the 11th term, and then tell me, what is the 11th term? What are we talking about? Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. So I used my recursive formula because that's what I was supposed to do. And I was like, okay, a sub n equals a sub n minus 1 plus d. My n is 11. I'm looking for the 11th term, so I plug that in, which means I need the 10th term. And I'm going to add my common difference d, which was 18. And then this is pretty easy. If I look at my table from the getting started activity, I can see that my 10th term is 287. And I'll just add on my common difference of 18 and find out that my 11th term is 305. Now, we were asked to go a step further though, right? We were asked to describe what it is that we just found, because we did just find something. So what this means is that Rico will donate a total of $305 if 10 home runs are hit. So notice that it was the 11th term in the sequence, but it was only 10 home runs that were hit. So it's always off by one, just a little bit there. So if I want to know, if I wanted to know how much he would donate for 10 home runs, I would have to make sure I'm doing the 11th term, okay? Now, I want you to think about this next question. I'm not going to make you calculate it right away. Can you think about it? Is there a way to calculate the 20th term without first calculating the 19th term? And if you think there is there a strategy? I don't know that you have an answer for this, right? Because usually in order to find the 20th term, wouldn't we need the one right before it, the 19th? But it turns out there is a way to do that. I'm going to show you. You can actually determine the 93rd term of a sequence by just calculating each term before it, right? You can make a giant table and then add 18 all the way up to the 92nd term, but that's probably going to take a while, right? So that's not very practical. So this recursive idea of I just add my common difference to the term right before it is great if you're finding something near where you left off. But if we were to say find the 93rd term, suddenly this recursive formula is really impractical. We would have to make a massive table that would take us a really long time to get to, plus so much room to make mistakes, It's not good. So there is a more efficient way to calculate any term of a sequence, and it's called an explicit formula. And yeah, that's our next keyword. You can see it's in bold right here in your workbook. So an explicit formula of a sequence is a formula to calculate the nth term of a sequence using the term's position in the sequence, okay? And here I have the explicit formula for determining the nth term of an arithmetic sequence. So this works a little different. When we did recursive, we needed to know the common difference and we needed to know the term right before it. But we said that wasn't very practical if I was looking for, say, the 93rd term, which is just difficult and a lot of work and a big table. So this one works a little differently. It uses its position n to help us. So what you actually need is you need the first term, a sub 1, and your common difference. If you have those things as well as knowing what term you're looking for, you're doing pretty good. So if I wanted to find the fourth term, I mentioned this example before, a sub 4, then I would do a sub 1, my first term, plus my common difference times 4 minus 1, n minus 1. I'm going to show you how this works. So if I wanted to find the 93rd term in the sequence, I want to find term number 93. And I don't want to make a big old table to do that because ain't nobody got time for that mess. I can use the explicit formula. A sub n equals a sub 1 plus d times n minus 1. So if I'm looking for the 93rd term, then everywhere I see an N, I'm going to plug in a 93. We know from this problem situation that the first term is 125, right? He's going to donate $125 no matter how many home runs are hit, even if no home runs are hit. And we also know that the common difference, that plus, 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 is 18. So that's where I'm going to put that in there for D. And now we're ready to go, right? If I want to find my 93rd term, I just got to clean this up. Please remember your order of operations. Make sure you take care of these parentheses first. 93 minus 1 is, of course, 92. Also remember that with our order of operations, our PEMDAS, that you need to multiply before you add. So I grabbed a calculator. 18 times 92 gave me 1,656. And yes, I used a calculator. Holy crud, use a calculator. And then, of course, if I add that to 125, I get 1,781. So it turns out the 93rd term of the sequence is 1,781. So this means that Rico will contribute $1,781 if the Centipedes hit 92 home runs. Please remember, 93rd term means only 92 home runs, all right? Always just the littlest bit off. Watch out for that. So now that you got a feel for this explicit formula and how it works and how we put it all together, I would like you to go ahead and use the explicit formula to find the amount of money Rico will contribute for each number of home runs hit. Not only do we have part A, we've got part B, C, and D. So please make sure that you're doing all of those parts. Go ahead and hit pause to work all 4 of those out on number 3 on page 135, and then hit play when you're ready to check your work and see how you did. All right, how you doing? So the first thing I reminded myself of was, look, if they hit 35 home runs, that's the 36th term, okay? You remember from our table how it was off just by 1? So 35 home runs is the 36th term. So fine, I'm going to use my lovely formula. I know N is 36. I know my first term is 125 and my common difference is 18. So I'm just going to plug everybody in. And then I'm going to clean up. 36 minus 1 is 35. I grabbed a calculator. 18 times 35 is 630. Plus 125 is $755. For B, we have 48 home runs. So again, remembering my table and how it was always a little off, that means that I'm looking for the 49th term. So when I use my explicit formula, everywhere I see an N, I'm going to plug in 49. We know the first term is 125. We know our common difference is 18. And then I'm just going to clean it up from here. 49 minus 1 is 48. Times 18 is 864. Plus 125 gives us $989. Part C, 86 home runs. This is getting insane. This is a lot of home runs. It's a lot of home runs. 86 home runs means I am looking for the 87th term. So when I use my formula, everywhere I see an N, I'm going to plug in 87. I know I'm going to substitute for A sub 1. My first term is 125. My common difference is 18. So I'll plug that in for D. And then I clean up. 87 minus 1 is 86. Times 18 is 1,548. Plus 125 gives us $1,673. And this last one is nuts. Oh my gosh. 214 home runs. That's a lot of home runs. Which means I'm looking for the 215th term. Yes, it does. So for N, I'm plugging in 215. For A sub 1, I'm going to substitute 125. And for D, I'm substituting 18. Subtract, and I get 214. Multiply to give me 3,852. Plus 125 gives me $3,977. You know what, though? Rico's looking at his contribution, and he's looking at these numbers, and Rico's like, that's kind of weak. I can do better. So Rico decides to increase not only his initial contribution, but also the amount donated per home run hit. So he decides to contribute $500. And he's going to donate $75 for every home run the Centipedes hit. So for question number 4, to get us started so that we can figure all this mess out, I would like you to write the first 5 terms of the sequence representing this new contribution that Rico is going to be donating to the Centipedes. Go ahead and hit pause, give me the first 5 terms, and then hit play when you're ready to check your work. All right, so first term is going to be 500. I know that. And then we're going to add 75 for every term after that. So my initial term is 500 plus 75 gives me 575. Plus 75 gives me 650. Plus 75 gives me 725. Plus 75 gives us 800. All right, so it looks like my first term is 500. And it looks like my common difference is now 75. Those are both going to be super important, right? That's our A sub 1. Our first term is 500 now. Our common difference D, it's not 18 anymore. Our common difference D is now 75. Some very different numbers we're working with here. So now that we know that we have these very different numbers that we're working with, I would like you to determine Rico's contribution for each number of home runs hit. So number 5, there's only 2 this time, part A and part B. So using this new information, new initial term, new common difference, go ahead and use that explicit formula to find the amount of money he's donating for these home runs for part A and B. Go ahead and hit pause to work those out. Hit play when you're ready to check your work. All right, people. How you doing? 39 home runs, if we recall, that means I'm looking for my 40th term, right? That was the deal. 39 home runs means term number 40. So I'm going to use my formula, and we were just saying that I'm looking everywhere I see an N. I'm going to plug in a 40 because that's the term I'm looking for. We said our new first term, A sub 1, is now going to be 500. And that our common difference D has also changed. That's now going to be 75. So I have some very different numbers that I plugged in here. But the process is still the same. So 40 minus 1 gives me 39. Times 75 gives me 2,925. Plus that initial 500 means that we are sitting at $3,425 that Rico will donate if they get 39 home runs. So what if they get 50 home runs? Well, 50 home runs means I'm looking for the 51st term. So that means everywhere I see an N, I'm going to plug in 51. My first term is 500. My common difference is 75. Plug those in. 50 minus 1, of course, gives me 50. Times 75 gives me 3,750. Plus 500 gives me $4,250. So if the Centipedes hit 50 home runs, Rico's going to donate a nice little chunk of change. Good job, Rico.